All right. Another day, another advent of code. Round starts in 60 seconds, so... Boy, might be a little too loud. Let me double check. See what's going on. Is my sound coming through okay? Let me see. Oh yeah, we're doing fine. Doing A-okay. All right, well, 37 seconds. We've got our stuff set up as normal. This, actually, we're gonna risk it, zoom in a little bit so people can see better. And over here. Yeah, that should be fine. Got level 3, part 1. We got it's pointing to the right text file. Everything should be great. 20 seconds. Oh. Hope everybody's had a nice day. There we go. Much sharper. Day 3. Let's copy the puzzle input while I'm chewing. Alright, looks like string parsing. One elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go in exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. The elves have made a list of all of the items currently in each rucksack, your puzzle input, that they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, A and A refer to different types of items. The list of items for each rucksack is given as characters, all in a single line. Hey, checkmate. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. The first rucksack contains this set of things, which means its first compartment contains the items this, while the second compartment contains the items that. The only item type that appears in both compartments is lowercase p. So we're looking for characters that show up in both. The second rucksack's compartment contain blah and blah. The only item type that shows up in both compartments is uppercase L. Third rucksack's compartment contains this and this. Only common item is this, etc., etc. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase item types A through Z are priority 1 through 26. Uppercase items have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack is 16, 38, 42, 22, 20, and 19. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities for that item type? Okay, pretty easy. So string line equals scanner dot next line. No problem there. And then we want to like split the line in half, but basically we just want to take the first half and put it in a set, and then we want to take the second half and see when it comes into that set, and then we're gonna do so for int I equals 0, I is less than so let's see, we want something like a hash set. Hash set character set equals new hash set. Wonderful. And we want a new one for every line, so this is great. I is less than line dot length divided by 2 plus I. So for the first half, we're going to set dot add line dot char at I. And for the second half, I equals line dot length over 2 plus I is less than line dot length plus I and let's get a cost going. Int sum, I guess it's priority equals 0. Priority sum equals 0. If set dot contains line dot char at I And then it's priority sum plus equals, and then we want to take the int of line dot caret I, and then we got to subtract something. So let me look that up. ASCII table, is that right? Yeah, here, let's look up the ASCII table where you guys can see it. Yeah, so the character, and it's kind of inverted. So if car misplaced equals line dot caret I, and we'll just go ahead and we can do the insertion here. And then what we want to do is if misplaced is if int misplaced is greater than 96, that means it's we want to do it this way. Sorry for the parentheses. That means that it's 97 or higher. So then we want to say we want to subtract 96 from it. So priority sum plus equals int misplaced minus 96. Else, and we can just assume that everything's going to be fine. Priority sum plus equals and what is it? It's int misplaced minus, and for the capital characters, we want, let me make sure that I'm reading this correctly. Yeah, so lowercase is 1 to 26. The upper one, so we want A to be 27. And in the ASCII table, big uppercase A is 65. So minus 64 plus 26, is that right? Yeah, so what's 64 minus 26? Let's get a calculator out. 64 minus 26 plus 38. Minus 38. And let's comment that. Lowercase. Uppercase. And this comment needs to go in here. Okay, so that should probably be fine. And then we want to print out, what is it? Priority sum. Is that right? Plus priority sum. All right, let's give that a shot and see how it goes. Run main. Immediate exception? Nope. 10,000. Not quite right. Let's return to day 3, and let's use this example then, and then we can print out as we go if we need to. So we can come back to that. Let's print it out. Let's see whether or not we get the right answer. And then, yeah, 237. And it should be 157. So clearly something about our summing is wrong. Let's see. Let's put a break here. Oh, and then we want to, it's probably, maybe it's doing this multiple times. So then if that blah, 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 we want to do that, and then we want to break. Cool. So let's see whether or not the break changes anything about what our sum comes back as. Now it does, which is a little concerning. But okay, so let's see if we put the data back, does it fix? It's not clear to me how that bug would manifest this way. Let's go ahead. So our number is smaller, which is probably good news. Okay, that's the right answer. Okay. As you finish identifying the misplaced items, the elves come with you to another issue. For safety, the elves are dividing their group into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of the 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. And at most, 2 of the elves will be carrying any other item. The problem is that someone forgot to put this year's updated authenticity stickers on the badges. All of the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Each set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines, And the next 3 lines. In the first group, the only item type that appears in all 3 rucksacks is the lowercase r. This must be their badges. In the second group, their badge type must be Z. Priorities for these items must still be found to organizer. Stickers attachment here. Here they are 18 for the first group and 52. The sum is 70. Find the item type that corresponds to the badges of each 3 elf group. Okay, this is easy. It's just a little different. So let's take this part, all of this stuff inside the try before this, and we still want a priority sum, but we're going to compute it a different way. So we can replace the try here for part 2, and when we go to main, why don't we go ahead and call part 2 before we do anything so that we don't mess that up later. So while scanner has next line, what we want to do is, so now we want to do this 3 times. We can call them first line, second line, and third line. And so the new hash set is fine. So now we want to find the thing that's common among all of them. So we can still use our set. So let's do for into I equals 0. I is less than first line dot length plus plus I sets dot add first line dot char at I. That's fine. We're going to do a similar thing, but we're going to create another hash set. And in fact, we can copy this and let's rename our first hash set as well. So this one, I think it's Shift F6. Yes. First line set. Great. So now the next one is first 2 lines set. And so now for into I equals 0, we can do this same part actually. I should have just copied this. 0, we want it to be second line dot length. Second line, no problem. And we want this to be first 2 lines set. And this is if first line set dot contains second line dot char at I, because we only want to add these to the second set if they're in the first set. And then what we want to do is and it's the same thing but for the third line, and then we can break third line if first 2 line set dot contains third line dot char at I. We want to do some stuff. We'll end with a break, and we probably want the same priority sum logic that we had before. Yeah, so we want this, except we want to rename the variable. This should be third line. This character needs to be renamed to badge character. And then it should still be fine. So I think that's all it should take. Let's run. 2585. Let's give that a shot. It's the right answer. All right, we nailed that. 1 gold star closer. So let's go ahead and look at the leaderboard and see how we did. So obviously we're not on this. Other people are just destroying us. But let's look at my personal stats. So today 1600 and 1400, which makes sense. This is a pretty easy one, and we didn't do it particularly quickly. But let's look at our personal leaderboards real quick. Private leaderboard. Look at my own. Oh yeah, and we crushed it. We beat. Looks like Brian's doing the 2 things right now, and I think we beat him based upon what our score was yesterday, because we had this minus 40, I think. So yeah, we won both the ones today. No complaining there. And if we look at our other private leaderboard, also still here. Yeah, that makes sense. No, hey Dev. Hope I'm pronouncing your name correctly. Maybe it's Noe. But yeah, that doesn't surprise me. You're stuck here listening to me. It's really distracting to be listening to somebody else while you're doing stuff. What's that?
Can I put the window?
Sure, why?
Because it's getting all the way through.
Okay, it's just freezing cold out there.
Okay, that's fine.
Yeah.
I'm taking my kid to the airport. I'll be back in 30 minutes.
Okay, all right. Which airport? San Jose?
Yeah.
All right. Have fun. You taking my car or you taking your car?
My car.
Okay, all right. Oh. Yeah, no, it's too efficient for me to copy. Yeah, well, it's also, yeah, it's just really, it's really hard to listen to somebody while you're trying to do stuff. Okay, with that interjection in there, let's take a moment and clean things up like we do every single time. So if I go back to here, we want to put in this.
My old phone.
Where's your what?
My old phone somewhere here.
Yeah,
Where?
it's up underneath the. Yep. Why do you need it for something?
Well, my phone doesn't have an aux cord, so I'm gonna use it for music.
Okay. That may or may not work, but good luck. All right, let's go ahead and full screen here. Blah, blah, blah. We can't full screen because I need to see what's over here. Nothing in the first one, nothing in the second one. The third one is the first one that we care about. Blah, blah, blah. Third one, every item, single uppercase or lowercase. So A and A refer to different types of items. Lists, given rucksack, 2 compartments. First half present first thing, second compartment. For example, 6 rucksacks. This, and it seems like these, it wants to be lists. Like this. Let's do that, and then let's, oh yeah, we can just double click to put the things in. That's so nice. Here. Okay, this, oh, nope, too much. Here, here. Here. So a lot of what coding is like. You think real hard, you do some stuff real fast. To prioritize. No, we don't need this to be a list item. Thank you very much. Those can be list items though. No, undo that. This. Just a nice little code cleanup. You know, how valuable is this to anyone? I don't really know, but I like doing it. I like having had it done. If I ever look back at this, I'll be glad that it looks so nice, you know? When I'm 50 and I'm curious what I was doing when I was 29. Part 2. Divided into groups, badges, item type B, of type B. Somewhere in the rucksack, and most 2Ls carry any other type. Blah, blah, blah. All of the badge and rucksacks know to Z, etc., etc. Okay. Lowercase r. Second group Z. Priorities 18 for R, 52 for Z, 170. Wonderful. Okay, so that seems fine. Let's go back and look and see if we need to clean anything else up. There's a bunch of, in fact, there's probably a small, let's do our first little refactor. So private int care to priority. And then we can copy what we had for the other things. So we want this, except we want int of this, then we want to, instead of adding it, we want to return this. Otherwise we want to return this. And so now we can just say priority sum plus equals this should be static. That's why we can't reference it. Here to priority batch character. And then we can do the same actually up here because this is obviously the same, except it should be misplaced. And in theory, we could put one of those inside the other, but you know, that's fine. Okay, so let's commit this. Commit and push. And the thing we're trying to commit and push here is, oh, let's put this back over. solution and readme for day 3, and then we'll explain what's going on and call it a night. And by call it a night, I mostly mean, yeah, this is great. We'll edit this into a YouTube video and push it. Cool. So push to origin master should be good. All right, let's explain and see whether or not we need to do anything else. So for part 1, we read in the input file, we open scanner, and then we keep track of a sum. For every line, what we do is we create a set, and for the first side, we just input the first half of the character, we just add all the stuff to the set, and then for the second half of the line, we see if the set has the character. If it does, then we add the priority of that character to the sum, and then break out. And then we do that for every line, and then we print out the sum. Pretty easy. For the second one, we read in lines 3 at a time. We create a set for the first line, and we add all of the characters to the set. Great. For the second line, we create another set, and we add stuff to that set, but only if it exists in the first set, which is a small optimization, but it's going to help us a little later. Rather than having to check both sets, we can just check the second set. And then for the third line, we just go through, and once we find something that's in both of the previous things, then we're done. And so we add the priority of that character to the sum, and then we print it out. Pretty easy. And let's go ahead and add a little Java doc here for this. I do not actually care about the return and whatever else. I just want to write returns the priority of a character. Returns the priority of a character as defined by a equals 1, ... z equals 26, a equals 27, ... z equals, what is it, 52? Yeah, that should be correct. And we just do that by interpreting the card directly. Cool. So let's add comments to day 3's code. Commit and push. Yay, you can commit all of this stuff. But anyway, push. Wonderful. Okay, all right. Well, that's all I've got for you guys tonight. I hope everybody has a wonderful evening. I'll be back tomorrow to do the same thing all over again. Enjoy the evening. Happy Friday, everybody. See you on Saturday.